I'm Nina, and I've been working in the peering community for many, many years. And now I'm here at Kentik talking about peering instead. And I'm going to go through a short use case about capacity planning, about what to do when things aren't going as smoothly as possible. Because I used to be a capacity planner, and it was easy. It was not easy, but it was a strict process. And we always wanted to have the right capacity at the right time. And some people would think it was boring when we talk about it. But right now, this is what the capacity planners are looking at right now, because our traffic is going up, but the delivery times on our gear is going up as well. So I'm going to try and show you how we can use our tool to get by that, and what to do, what you can do while waiting for the gear to show up. So last year, Greg Milan was talking about what we can do when interfaces were running full, and was showing our traffic engineering module. But today I'm thinking a little bit more about when memory runs out, when the CPU runs out, and what can we do when that happens? Well, the solution there is often we need to know what our traffic is, what is the important traffic, and can we move that traffic around? Can we remove some of the prefixes that are overloading our BTP process on the router? And so basically, if we want to try and be chasing the traffic, chasing what is the big traffic and what is the big amount of prefixes that might not give us a lot of value, but we're taking it in because we joined an internet exchange and is using a route server and getting everything for free, and it should be so good and with so good quality. So just a quick reminder on a route server. So if you're on an internet exchange, you can do like one session to a route server, and you're getting routes from every other participant on the route server sent to your router. It seems like a really good idea, except if you're not getting a lot of traffic, but you're getting a lot of prefixes, the proportion might not be good. So we'll just look at how can we spot that, and how can we fix it as well. And I have to say, I'm talking about the situation and the traffic that is left when we've done through the motions that Steve was talking about in our previous video, when he was talking about the OTT services and the CDN analytics. We're assuming that all of that is taken care of for this type of use case, because it's we really don't want that traffic running this way. So here I am using a quick screenshots where we're looking at our data explorer and just finding which are the big traffic sources that we have coming out of a IX interface where we're pretending we're only peering with the route server. So we see that we have quite a bit of traffic from Telecom South Africa. This is all made up data, and a little bit of traffic for telecom internet. But we're still seeing a lot of prefixes coming into our router, and it's not doing well. So what can we do? And here we can actually use KMI, because remember, when you're using a route server, you have one session. So you're getting all of the prefixes in one session and all the number. So you can't go in and say this ASN is a lot of prefixes and not a lot of traffic. But we can use the information that we have in KMI to, first of all, identify that there are customer relationships from telecom, between telecom and telecom internet, and also go and see that when you're looking at telecom internet, they're originating almost 2,000 prefixes. But if you're looking at their provider, they're originating only 100 and only transiting less than 1,000. So a possible way of fixing our router issue with the memory or the overloaded BTP process could be to only peer with the provider telecom and de-peer de-peer the route session and only take in the traffic from the provider. We will have the customer behind it. So basically, do a selective filtering and entering into a selective peering policy, where we take care of looking at traffic volume, but also the amount of prefixes that are coming in. So if we do...
Can I jump in at that point there? How do you take care of the other direction? I mean, obviously that takes care of the upload, but how are you getting rid of the download?
Getting rid of, well, here, the download, that would be looking only at the traffic volume, right? Because that would be your prefixes being announced. So the use case I was looking at was when the router was overloaded, not by traffic, but overloaded by processing the number of prefixes. Of course, if you do have a lot of traffic to that, if you do get a lot of traffic from that provider, it's not a good idea to de-peer that one and send it through the peer, or maybe it is. You will have to figure out whether what is the path from them going to you, and also what is the your question was, what about the traffic going in the opposite direction? So the traffic coming from that network that I proposed that we de-peered, so they would be sending it to us through their provider.
Right, you're setting up an asymmetrical routing thing that can black hole a session, essentially.
No, I'm not setting up
Sure, you're getting rid of prefixes that I can't upload to, but they can still download to me. So there's a possibility, depending on where these prefixes are elsewhere in the network, that it's only going to have one-way traffic.
Are we talking about one-way traffic or one-way peering announcements with the expectation?
I'm not talking about a one-way peering announcement. I'm talking about not having a peering relationship over the route server with that network anymore. I'm talking about just peering with their provider.
Oh, so you're talking about getting rid of that,
yes.
That peering. I thought you were talking about applying a filter to that peering relationship and dropping just some of the prefixes from them, which scared the hell out of me.
No.
Yeah, well, as long as I secure that there is other paths to the same prefixes, it would be okay. But again,
that's a pretty big if.
Simple way would be to completely de-peer them, and then we don't have to be afraid of that. I agree with that. Okay. Yeah, but what we can still be concerned about, of course, is that will have a major impact on the quality of the traffic. Maybe because they don't have enough capacity on their link to their provider, or just the traffic will be tromboned in certain ways. So this is where, when you do that, we propose that you do establish monitoring of that ASN that you will do it for. So again, here, what I'm proposing is setting up the ASN test that we talked about a little bit earlier, because you asked the question to Steve about how to monitor the quality a little bit closer to the CDNs. And we do have some of the predefined synthetic text that we have, or is an ASN test, which I propose that we would be using for that situation. So basically, we have the peer network. We're now using the peer network to reach their customers instead of peering directly with the customers, simply because we are out of resources on our own gear. And I wanted to show you, when we want to set up that kind of test, we go into a test control center. And I just want to make sure that we have a quick overview. Again, last year we were introducing our synthetic test, and our colleague Anil was talking about all of the agents that we have all over the world. In the situation we're talking about here, we will only be looking at the private agents inside our own network that we can use to monitor elements outside of the network. And when we want to add an ASN test, we can add a test by easily just go into add test. And then we have these predefined types of tests that we can use to set it up. And I'm looking at an ASN test. And here we're using, as Steve was describing in the other video, we're using our either inbound or outbound traffic to find the relevant ASNs to test. So if we pretend right now that it was maybe China Unicom that we were doing this motion for, we could then select China Unicom, and we will buy outbound traffic. We would be able to see where, which of our sites are the traffic coming from, and select agents from each of those sites. I'm not going to create the test here because we don't have the agents configured in our test system. But I will show you a little bit more about the advanced options for this kind of test and talk a little bit more about what it is that it does. Because it is set up for picking the ASNs that we want to pick. So we chose an ASN. Based on the ASN, we will then go into the flow, go into that ASN. Outbound traffic was what I was asking for, and then pick the relevant targets. So the most relevant targets to monitor. And in our options, we can then go in and say, well, how many targets do we want to have? Every time we reconfigure the test, we will have 10. And how often should we scan the flow to figure out what are the most relevant targets to monitor right now? And here it sets for 12 hours, but we can pick every hour, every 3 hours, every week, depending on how often do we see the traffic change and how important is it for us to catch the changes right away or just maybe over time. Same thing, we can go in and configure more about what kind of ping we will be using based on what type of traffic I'll be monitoring. Would it be TCP based? Would it be UDP based if we're looking at the trace routes? So what I will show then is if I want to look at an ASN and I just want to make sure, well, how is it going right now with this ASN? And I would like to look at DigitalOcean. DigitalOcean, we can pretend is a network that we did this with earlier on. So how is the traffic to this ASN? And notice that we have just in our search, we can go and I'm searching for just the AS number, and it comes up with, it could be an ASN, it could be a test. I happen to know those tests are here. And it could be other things related, other ASNs with the same numbers in. So looking at DigitalOcean traffic, we can see that we have a decent amount of traffic that we want to look at. We can see which interfaces it's coming from, which prefixes and how many prefixes is taking what amount of traffic, what sites it's coming out on. Again, also split on the different directions. And we can go in and have a look at what the ASN monitoring test is looking like. And here we're in this test again, pulling in on the flow data. So we have the targets that have been picked by the test, the traffic that's going to them, and it's going through transit, and it is going through these three providers. And we can also see that we have warnings and critical warnings about something is not completely right. And we can have a look at and see whether it's the provider that have a problem or whether it is with the target maybe. So we really want to have a look at the past view. So we can go and dig in, and this is just basically trace routes. So what we're doing here is trace routing from agents and then making a visual representation of the trace routes. So we can go in and pinpoint where might the issues be, and more importantly, figure out, is this an issue created by the traffic engineering we did, or is it an issue that is out of our reach and we just have to wait it out or maybe move some traffic somewhere else. So the last thing I just want to talk about is I had an example where I would move or de-peer a potential peer and set up a direct peering with the provider. Another way of limiting the load on my BTP processes could also be to move some traffic over to my transit. And in particular, moving traffic over to my transit, or just in general, moving traffic around, when you do that, you need to make sure that you understand that you're not increasing your cost because you have to move it somewhere. So the cost tool that we have comes in handy. It doesn't do exactly what was requested before. It sounds really like a good thing. But what we can do is that we can configure the cost model for all of our connectivity. And this has been done here. So this is basically all the private peering, or it could be all the peers that we have, where we can assign both the contractual cost for the networks where we have a contract and we're paying them for the traffic in one way or another. And we can also add the network costs. So we know that in this POP, we have this really expensive router. So we should have, make sure that if we add an interface there, we know what that costs. So we can all model that into this tool.
Is this tool also able to accommodate that you have a base cost and a 95th percentile over a level, that type of thing?
It does. So let's have a look at how that all
Even
is
if
done.
you have global commits with regional average 95ths and averages and all the craziness that.
Oh yeah, makes my head hurt
have
every month when we did the reports.
We can have it. We can add it all. So we can have here. If you look at the AT&T communications here. First of all, let's have a look at the view of the provider, and we can see that this provider is split into two different contracts. So we have the cost on the different contracts, and looking at the traffic that we're sending on that contract, we will also get what the actual cost, what the cost per megabit is, and the traffic flows that we have. And we can track the development in the cost per megabit, the effective cost per megabit over time, to make sure that, if you have a high commit and you're not sending any traffic on an interface, it becomes really expensive per megabit you're sending. And this is also the tool that you can use to go and maybe find a provider where you haven't met your commit yet. And that means you can move peering traffic over there at no cost for you, because you still have room in your commit. So this is why I wanted to bring that up in this discussion.
I think so. One point, Nina, I think it would be useful if Kentik could offer a way for providers to almost bid on the information in a customer's portal, right? So like if NTT, for example, if NTT has additional capacity in Newark and they want to have a really aggressive pricing model selling transit in Newark data center, 165 Halsey, they could go to Kentik and say, hey, give us some API endpoint where all customers with traffic running through Newark, if they're customers of Telia, put it at 0.01 per gigabit, something like that. I feel like you could leverage this to make it a very sort of competitive platform for providers and Megaport Packet Fabric too.
Yeah, I'm not sure all of our customers would enjoy that we were using their data that way, but.
Well, no, it wouldn't share it with them. It would be more like an offer. It would be more like an offer. But the same thing, PeerMaker. I don't know if people remember May East and stuff like that, but people ask for that, which we think about, which is, well, okay, so you're both customers of Kentik. Can we just can you connect us to each other, and then we approve it? We have our automation system set up stuff. The thing we won't do is we have customers that want us to introduce them to other customers who are bad BCP38 actors, and so we have to, we'll offer, but we're not going to publicly shame our customers. But to have a feed of something that shows up if you opt in that says, hey, someone's offering specials in an area where you're paying more, that's definitely something we could look at.
So let me just show how we configure the different contracts. So here we had 2 different contracts, and you can see that this, if you look at the North American contract, it has some global charges, it has a commit, and then it has a tier, so the price is dropping as you're adding. So we're able to model all of that into the tool. And also we are able to add the different interfaces that we have in our network. And they will come up automatically based on if we have classified it correctly and have good descriptions and good search abilities in our configuration.